We are going to see about the overview of power system analysis. So, what is power system? A power system consists of your generation, transmission, and distribution. That combines your power system. Okay. So, what are the main components of power systems? Are generators, transformers, transmission lines, distribution lines, distributor lines, loads, and compensating device like shunt, series, static wire compensator. Okay, so if you take the power system, so definitely you'll be having your generators, transformers, transmission lines, your distributor lines, okay, and loads will be there, and so compensating device like a static bar compensator. There and there it will be there. Shunt compensator will be there. Series compensator will be there. So together forms the your power system. So or otherwise, in the other terms, these are the components of the power system. So, in order to maintain this power system, a bulk power has to be transmitted, okay, through transmission and distribution lines to the consumers safely and economically. Okay, so it has to transmit. We have to transmit to consumers safely. That we are doing, and economically. What is the word economically means? So, so whichever the generators we are choosing, that should be least cost generators you should always choose. Okay, say for example, if you want to if you want to compensate a load, like if you want to provide a power to particular loads, so you need to choose the optimal generators. Optimal generator in the sense which is very least cost. Say for example, if you choose the thermal generators, it will be the cost might be going on more, because if you take the per unit per kilogram of lignite, okay, pure lignite, so it may varies from 12 rupees to 18 rupees or 20 rupees, okay, so per kilogram. So imagine if you want to generate 1000 megawatt or 1500, 2000 megawatt, so you need to spend tons of coal, tons of coal. So you see the thermal is the costliest one. Okay, and if you take the nuclear system, one time you need to invest. One time you need to invest, because constructing the nuclear power plant itself will take minimum 4 years. Okay, minimum 4 years at the maximum 6 years, like that. But minimum 4 years it might be take. But the thermal generator and nuclear generator almost same. Only thing is that the fuel only varies. Okay, so here you are using, in the thermal we are using the coal, but in nuclear we are using that nuclear reactors, like nuclear reactors, and that a particular uranium or okay. So that particular nuclear that fuel is costly. Okay, so if you take like 1 kilogram of that particular nuclear fission reaction, you already studied in your basic your power systems. Okay, so what nuclear will happen is, so if you buy a kilogram of that nuclear fuel, 1 kilogram of nuclear fuel, once it is being bombarded, once it is being bombarded means, so that fission, nuclear fission will keep on going. You can't stop that nuclear fission. Okay, so that's why you are using graphite rods. If you go to the construction of the nuclear power plant, so for just stopping that okay, nuclear fission reaction, stopping that heat, we are using some graphite rods. So once it is being bombarded, so that nuclear fuel may run for 3 months or 6 months or year also. It depends on the how much kilogram. But that nuclear fuel is costly. That nuclear fuel is costly. So that is, and if you take the hydro power plant, so that is cheaper. No need of paying okay, any cost for utilizing the water. Okay, until otherwise, if it rains and river flow is there, then happily you can use this water resource. And renewable also, no need to pay for utilizing wind or air like that. So it is also free. For utilizing light also we are not paying. So it is free. But construction installation, it will take more time and also costly. Okay, if you take PV solar cells, then installation will be very costly, and also lifetime of that particular PV also maximum 10 years to 15 years. How you are maintaining, okay, depends on how we are maintaining. And wind turbine also little bit maintenance cost is there. So these are the general. So economically, we are utilizing this passes that you need to understand. So next, evaluation of power system is called uh, this power system. So we are evaluating how the power system is being performed. So that we are evaluating in this subject. Okay. So in monitoring power system, we are mainly dealing with power and load flow analysis. Okay, so we are making the load flow analysis, next is short circuit analysis and stability analysis. So these are the very major analysis we are going to make in this syllabus, in our curriculum. Okay, next, what are the functions of power system analysis? The main function is to monitor the voltage at various buses, that is real reactive power between the buses. Okay, so we are monitoring the voltage between the buses. Okay, so that we are making, and to design the circuit breakers. So design the circuit breakers correctly, because so any fault happens, your particular system has to trip. Okay, so for that, designing the circuit breakers plays a major role. Okay, so if you are just providing a random circuit breaker to a particular line, okay, suppose any fault is happening, then the entire power system, that particular part of the power system will be get damaged. And for if you are going to rectify that, you need a huge amount of money. You need to invest huge amount of money on that. So that is very important. So um, this is designing the circuit breaker. Next, plan for future expansion. Okay, say for example, if you are planning a power system, definitely you need to plan for future expansion, because say for example, if the particular load of your street or something is some kilowatt, okay, some kilowatt or some megawatt, say for example 0.25 megawatt, but you need to plan that a particular system for maximum 1 megawatt, like that. Okay, if you plan for 1 megawatt only, future we don't know. So okay, so due to industrial revolution and due to population, automatically the load will increase day by day. Say for example, if you take the load of this particular time throughout the India, it is some gigawatts or some megawatt. Okay, say for example, 1,70,000 megawatt. Okay, say for example, tomorrow, because summer is approaching, tomorrow it will be changing 1,71,000 megawatt. So 1,000 megawatt might be increasing. Okay, or some 500 megawatt might be increasing. Day by day, it might be increasing only, not decreasing. So planning the future is very important with the power system. Okay, so even a substation, if they are planning also, they will do like that only. Okay, if the load is 1 megawatt, they will consider the substation for 2 megawatt or 4 megawatt. Because if because future extension is very easy. Okay, so they will keep instead of one feeder, they will keep 4 feeders. Instead of one transformer is more than enough, 1 or 2 transformers, but they will install 6 transformers, four to 6 transformers, because sometimes fault also might be happen, sometimes load also might be increased. So feeder you need to take one more. So like that, it might be increasing. Next, to analyze the system under different fault conditions. Fault condition in the sense, say for example, three-phase fault, we need to analyze. Next, line to ground fault, line to line fault, double line to ground fault. So these are the fault. Okay, so these faults, how to, what are the causes of the fault, that you studied the earlier classes. So no need of explaining. Next, to study the ability of the power system for the certain disturbances, for large disturbances, there is sudden application of large. Suppose, say for example, in a particular, as I said, if the summer is approaching, suddenly the load will become more. Okay, say for example, everyone use their ACs in their houses. Everyone use their ceiling fan. Okay, everyone. So ceiling fan will run for 24/7. Okay, maybe 1 hour you may give rest. Okay, it will be at the ACs you will go use for some 12 to 18 hours. Okay, 18 hours you will be using. So the load might be increasing like anything, and the large load suddenly the load is will be increased. So for retaining that load and for handling that load, so the system should be long term. It has to be designed. So then only easily we can do the things. Next, to study the ability of system under small disturbances. Say for example, some transients happening, some sudden, say for example, in rainy season. Okay, so you'll get the lightning suddenly happening in the system. So that particular system has to tolerate that particular sudden raise in the tranche. So that system, so small load changes also, some routine load changes also we need to analyze. To study the ability of the system under the large disturbance and as well as small disturbances, you need to analyze well. Okay, so then it will be easy for you to do that, manage that particular disturbances or faults or any load inclusion or exclusion, anything you need to withstand. Okay, so we need to withstand that particular thing in our power system. Next, structure of power system. Okay, so this also already we studied, just a glimpse. Okay, so in India, if you take the generating station size. Okay, so these are the different generator size, like a 6.6 kilovolt, 10.5 kilovolt, 11 kilovolt, 13.8, 15.5, 25 kilovolt. So these are the some of the generator ratings throughout the world. Okay, so more than 25 also there, and mainly if you take mainly in India mainly the previous days they might be going for this 6.6 kilovolt and 10.5 kilovolt like that. But if you take last 15 years or 20 years, so majority of the generators comes with the size of 11 kilovolts and 25 kilovolts. Okay, they are not following in between like that. Okay, so majority, if you take 11 kilovolt, and if you take the more thermal power station, it might be of 25 kilovolt. Okay, if you take the hydro power station, it might be of 11 kilovolt of some four sizes, four generators might be there. Okay, so if you take the hydro power station capacity, it might be of 100 megawatt, maximum is 100 megawatt, or 100 into 4, like stages will be there. One stage 100, like that, four stages might be there, 100 into 4, 100 into 2, 100 into 1, like that. The stages might be differing based on the size of the dam and capacity of the water and like that. But if you take the thermal generating units, a majority of the thermal generating units, they are following this 25 kilovolts. Okay, because the generation is more. Say for example, it is a minimum 500 to maximum 1000, 1500, and in some cases 4500 megawatt also there, like stages, not one generator 4500 mega, stages, 1000 into 4, okay, 500 into 1, like that. So it depends on the your load and as well as capacity of the coal. So what is the capacity of the coal resources, capacity of the resources and all. So majority in India we are following this 11 kilovolt and 25 kilovolt. So this is the being generated and it is transmitted over long distance. Okay, if you go to your thermal generating units, the size, the step-up transformer size might be of 25 kilovolt bar, 400 kilovolt, or sometimes 765 or 1200, like that. It depends on the distance. So how much distance it is located from the city to that particular city or the state capital. If you take Telangana, the state capital is Hyderabad. Okay, and if you take the thermal power station, it is like Kottagudam, like that, a very far distance. It is minimum 300 kilometers far. Okay, 200 to 300 kilometers far. Okay, so it has to travel from that part to this part to the state load dispatch center. and from that dispatches being happened. So here the step-up transformer. If you take the step-up transformer of this thermal power station, it might be of like 400 kilos. And if you take some, say for example, if the generating station is near to your load dispatch center, then they might be using some 200 kilovolt also. But here, this is the setting. This is the step-up transformer of size 11 kilovolt or 200 kilovolt. But some other size might be of 400 and 440 kilovolts, like that also it is there. And it is being transmitted over some distance, some distance, as I said, like 300 kilometers or 400 kilometers. And again, what we are doing is we are stepping down to like a 400 kilovolt bar 220, and sometimes 220 bar 110, like that. In between, that is a switching substation. That is called switching substation. So they will be they will be having switching substation. Say for example, if you are traveling into a long distance, you will be finding that switching substation. Okay, that size might be of 440 bar. 220 kilovolt or 220 bar, like 110 kilovolt, like that. It depends on the your usage and how much distance it may be traveled. Next, the step down transformer, that is receiving station. So this 440 will be converted into 110, 220, and 220 is again being converted into some 66 or 33 kilovolt. Okay, 33 kilowatt. Again, the secondary transmission lines comes into the picture. Okay, so again it is traveling to some distance, some 60 kilometers or 30 kilometers, like that. So again it is goes to some secondary substation. So this is called substation. So this is a single line diagram. So where you are having only one substation, secondary substation. But if you take the practical like a power system, it might be of many substations might be there. Okay, n substations. Okay, depends on the load. Okay, so in this secondary substation, the 33 kilowatt is being stepped down into 11 kilovolt, 11 kilovolt or 6.6 kilovolt. So majority we are going for this 33 bar 11 kilovolt only, because 6.6 is lesser. Okay, so because nowadays load is being increased, maybe it is 6.6 kilovolt and all. Maybe 25 years back we might be using, but now majority of the 6.6 it is converted into 11 kilovolt. Only few, not two. Okay, that too in remote places you will be find out this kind of substation. But the majority is 11 kilovolts. Okay, 99% you will be finding this 33 bar 11 kilovolts. That is substation. So again, it is being traveled to some consumers want the whole 11 kilovolt itself. Okay, so because industrial type, they are the big consumers. Okay, so their load will be more. So they will take 11 kilovolts directly, or otherwise 6.6 kilovolt or 3 kilovolt, like that. It depends on their load. That is all big consumers. And again, it is being transferred to some kilometers, some 5 kilometers up to 10 kilometers. So primary distribution. Okay, so you will be finding nearby your homes. Okay, so that is primary distribution line. It will be of 11 kilovolt line. Okay, so then you will be finding the transformer. Okay, like a transformer nearby your streets. So that is in that transformer. What is the rating of the transformer? Is 11 kilovolt bar 450 volts. Okay, so that transformer you will be finding majority of the place. Okay, nearby your streets, maybe the 2 streets once or 3 streets once, depends on the number of houses you are having in that particular street. So you will be finding majority of the this transformers. That is a 11 kilovolt. This transformer rating is 11 kilovolt per 415 kilovolts. Okay, and it is going to we are taking single phase lines or 3 phase lines, service mains. Okay, and to the consumers and to many consumers, not only one consumers, many n number of consumers may be there. So we are utilizing. So being a single line diagram, here it is only one transformer. But if you take practically, it will be many n transformers. Okay, distribution transformers. Distribution transformer size is 11 kilowatt per 450 units. Okay, so this is the structure of the power system. Okay, so sometimes they will ask in 2 mark questions. Okay, structure of transformers. So next topic is need of power system analysis in planning and distribution of the power system, the planning and operation of the power system. So what is the need? What is the need? It covers the whole period ranging from incremental stage of the system development. Okay, so the main thing is the system operation engineers at various points like area substation, like a regional substation, national load dispatch centers, and the load dispatch centers. So there they will follow this generation is equal to demand. But here, there will be not only generation is equal to demand. Okay, so if you take in power system operation control, we'll dealing with this generation and demand plus losses. So generation equal to demand plus losses. Definitely losses might be there. Say for example, your distribution companies are claiming the losses as 15 megawatt to like a 10 megawatt. 10 megawatt to 15 megawatt like that. So previously it is like a 18 megawatt, 20 megawatt. Now due to more distribution transformers, you will be finding more in your nearby your streets. So previously a distribution transformer you will be finding very less. Like I am telling about 15, 20 years back, you'll be finding. So after 2010, after huge crisis happened, so after that, what happens is your union government installed the under the APRDP scheme. Okay, so accelerated power reforms dispute scheme. So in that scheme, they have installed many distribution transformers, so that your losses in the distribution side is somewhat decreased. Okay, so now the distribution stations are claiming that the size will be like losses will be reduced to 10 megawatt, 10 to 15 megawatt. Okay, so but definitely losses might be there. So generation should be such a way that to meet out the required demand. Okay, so using the above relation, that is demand plus losses. Generation is equal to demand plus loss. So this above relation satisfies, gives a good economy and also security of the system. Okay, so the operation of the power system must be reliable and uninterrupted. Okay, so your power system should be reliable and uninterrupted. Like we need to give the power for 24 by 7 into so 24 by 7, 7 days in a week, and also 365 days. Okay, without uninterrupted power supply. Okay, so say for example, 5 minutes power interruption. Also, how we may feel. Okay, without ceiling fan or without ACs or without refrigerators, washing machine. So without 5 minutes power interruption, also we can't lead our sophisticated life. So reliability of the power system implies the more than the availability. Okay, so availability of the power. Okay, so the demand is more, but the generation is somewhat less. Okay, nowadays because the load is increasing like anything. Because every festival time, what we are doing, we are upgrading our appliances. We are buying new refrigerator of 500 liters. Okay, instead of 200 liters, we are taking away the 200 liters. We are buying 500 liters, and instead of 1 ton AC, we are buying 1.5 ton AC or 2 ton ACs. Okay, so like that load is increasing like anything. So expansion, okay, electric area is large in size, so planning for future expansion also essential. So more network data must be collected for planning this power system. And planning the power system So power system engineer use computer program. So that's what we are doing in this subject. We are programming this into software, and we are trying to solve the problem very simply. Okay, that is the subject. This is the main core of the subject. Okay, so whatever the problem we are planning with the computer programming, and we are doing the things.